Hi everyone, another video, another go at the productivity dataset. I thought this time we'd have a look at the relationship between capital productivity and multi-factor productivity. Here's a word to the wise. It turns out that the ABS calculates a multi-factor productivity by a combination of labour and capital productivity. So we'd assume there'd be a relationship between the two. Let's start off by creating ourselves a scatter plot on this one. I'm going to insert, if I can get past the, I can't get past the, there we go. I insert, here we go. Okay, perfect. Scatter plot, okay. Oh, look at that, that's a mess. That is a complete red hot mess. Let's see what we can do to fix this up. And basically what this is saying is that time series and scatter plots don't particularly go well together, but that's what we've got. Okay, let's just, let's actually mess around with these axes, I think. What are our axes options? Here we go. I think we'll take a minimum of 88. That really doesn't help us much, I don't think. Let's try this axis. Okay, just double clicking on that. Here we go, axis options. So I'm going to take a minimum of 95 and a maximum of 140, and we'll see if that gives us a graph that's a bit more sensible. Okay, so what you can see here is that there is some relationship here. It's really not clear just from this alone, and the reason is that this is a time series observation, and let me just show you why that is. So if I was to take these two, oh what the heck, let's do all three just for the fun of it. Yeah, that looks a lot more sensible, doesn't it? So if I select data, we can then put in some x-axis labels, which are actually the dates. We've got a pretty decent chart, which really does need a chart title, but we won't worry about that now, of what's happening with productivity. Okay, the date does matter. There's clearly some trends going on in here. Let's see if we can work out what the correlation between capital and multi-factor productivity is. Let's go to Tools, Data Analysis. I'm going to go to Correlation. You can do covariance. I find correlations more useful. Okay, so all the variables that you're going to look at here, group by columns. There are labels in the first row. I'm going to get an output range here because it just makes sense to me. Just put it there so we can see it. I did have an output range. Okay, so that's our input range, output range. Why does it move sometimes? I don't know. Okay, bingo. So we have our correlation matrix here. Once again, that's impossible to read with 7 decimal places. Just flip it over. Okay, so there is a negative relationship between capital productivity and multi-factor productivity. That's interesting. Of minus 0.54. Let's have a look what happens if we actually calculate correlation for all 3 variables. I think that might be an interesting concept. Let's have a look. So we're just going to overwrite what we've already got here, and that's fine. Okay, see? That is interesting. So when we include everything, there is a correlation between labour productivity and capital productivity of minus 0.93, and that makes sense from our graph here, right? As capital is coming down, labour is coming up. We have a correlation between labour productivity and capital productivity of 0.8, and we also have a relationship between capital productivity and multi-factor productivity of about minus 0.54. Okay, let's see if we can build ourselves a regression around this. Now our focus is on simple linear regression, which means one variable. Let's do that to start with, and then I'll show you the bells and whistles version for fun. So we go to regression. Okay, the input y range, that is our dependent variable, which in this case is multi-factor productivity. Our x variable will be capital productivity for the moment. Okay, there are labels. This constant is 0 here. Unless you have a very compelling reason to do so, do not click it. We don't need a confidence interval at the moment. I'm going to put this on a new worksheet because it makes it easier. Then I also want to show you some fun things here. We'll just do residual plots. Okay, so I press OK, and here we are. We have a multiple r squared. We don't need that at the moment because we have only a simple linear regression, so we just need r squared, which is 0.29. So it's about 30% of the variation in multi-factor productivity is explained by changes in the level of capital productivity. We have 21 observations. We have our ANOVA table here. We have an F statistic of 7.83 or 7.84 with a p-value of about 0.01, so it is significant. We have a coefficient here of 0.14, so minus 0.14. That means for a 1 unit increase in capital productivity, we would expect a minus 0.14 decrease in multi-factor productivity. Okay. This is a significant result, but is it one that makes sense? I mean, really, you would expect that any combination of productivity which is made up of capital and labour should really have positive inputs for both, right? There's something going on here. Our residual plots, a bit interesting there. Let's go back and look at our time series here. This is clearly got something to do with time, right? There's a time trend here. One's going down and one's going up. And this is just foreshadowing a few things we'll talk about in a couple of weeks' time. What I'm going to do is I'm going to make a more sophisticated model. Okay, I'm going to add a time trend here. So when we want to add time into a linear regression model, we do so by starting at 1 and going up to wherever you're up to. Don't just put the years in. I'm also going to make this model a little bit more complex. I'm going to add labour as well as capital productivity. Okay, so let's do that, shall we? So data analysis, going to regression. Okay, so that is no longer the correct range. So here's our dependent variable, multi-factor productivity. Here is our input range. I'm going to include labour, capital and time. Okay, I'm going to put that in a new worksheet. We'll throw some residual plots in there. Do not click the constant is 0 unless you've got a compelling reason. Okay, so we have an adjusted r squared, which is a correct measure to use when you've got multiple variables, of 99%. So we can say that 99% of the variation in multi-factor productivity is explained by this model. Okay, in our ANOVA table, we have an F statistic of 764. So the null hypothesis behind this F statistic is this model basically just a mean and an error? Is that as good? That's the null hypothesis, and we're rejecting that rather thoroughly. Having a look at our coefficients, let's just change the decimal places on this so it's actually intelligible. Okay, with an intercept of minus 15.5, which is not particularly interesting. We have a positive input for capital productivity, and that's what we'd expect. Whenever you have a model and it comes back with an estimate that doesn't make sense, stop and think for a second. It's probably misspecified. So by adding all the bits to the model that we needed, we've got a much better model here. So for a unit increase in capital productivity, would you expect a 0.6 unit increase in multi-factor productivity? For a unit increase in labour productivity, we'd expect a 0.3 increase in multi-factor productivity. There's also the time issue here. For each extra year, we'd expect multi-factor productivity to increase by 1.27 units. Now there's something I missed from all of those interpretations, and that was holding all other things constant. When we explain a regression coefficient, we need to hold all other things constant unless there's only one variable in the model. Now if we have a look over these residual plots, okay, that's our time plot, labour productivity. You can see this up and down motion happening here. It's kind of like waves. It's very tight here. Probably fix that. And there's another up and down motion here. Looks like there's some autocorrelation in this plot. That is that what happened last year matters this year for productivity. And that's not too surprising. We might discuss that a little bit in coming weeks. Okay, so that's how you do basic regression and a little bit more complex regression. So this was our more complicated regression. You can see the results are quite different. Okay, we had a negative relationship apparently with capital productivity, but what we really needed to include was time and labour productivity. Okay, I hope that makes sense, and I hope that gives you the skills that you need to run your own regressions in Excel. Please don't hesitate to ask me if you have any questions.